Welcome back to my channel, Kishore Sir Ki Pathshala. We were doing chapter number 3, Atoms and Molecules, 9 Cbse. Let's see today's thing. You might have observed a building made up of brick. The walls, if you see, is nothing but they are made up of brick, and that walls make a building. That collection of walls make a room, and that room makes a building. Similarly, the building blocks of all matters are nothing but these are the atoms. Means what you see in a building, you see the basic thing is the brick, right? So this is the brick what you see, which makes the wall, and that wall, see this, this makes the wall, and this wall makes a building, right? Like this, if you see matter also, the basic thing in matter is nothing but its atoms all about. Right. Then let's see how big are atoms. Atoms are very small. Literally, they are very, very small. Anything that we can't imagine itself. More than a million of atoms when stacked together, right? See this, the millions of atoms stacked together, that will make a thick sheet of a paper, right? So imagine the atoms, okay? They are very, very small as such. Okay. Then what are atoms basically? Right. Atoms are very small, as we have talked about, right? They are smaller than anything what we can imagine as such. Okay. So now atom, we know that it is a smaller one, it's like this, right? So how to calculate? See, this is the atom, and if this is the atom, so this will be the radius, right? So atomic radius, this atomic radius is measured in nanometer. It's measured in nanometer, right? Okay. So what is the relation of nanometers with a meter, right? So 1 meter is nothing but it 10 raised to 9 nanometer. But we must remember 1 meter is nothing but is 10 raised to 9 nanometer. This is the relation of meter and nanometer as such. Okay. Now let's see. We have talked about atoms. Now we know that element is nothing but they are made up of one kind of atoms. Elements are made up of one kind of atoms. Means what? A similar kinds of atoms will be there in an element. Okay, for example, if we take oxygen element, right? What we see, all the atoms are of similar kind. Okay, one kind. So Dalton was the first scientist to use the symbols for elements in a very specific sense, right? So now we have got so many elements as such, right, which have been discovered. So for every element, there will be some unique atoms, a group of atoms will be there, right? So what we need to give a symbol for a particular element, right? So that we can recognize it. So earlier, very few elements were discovered. So it was very easy to give the symbols as such. So Dalton has given few of the symbols like this. See this. For hydrogen, he has given a circle and a dot inside. Carbon, a circle was there, okay, along with color. Oxygen like this, right? Okay, so this was the earlier stage where Dalton has given the symbols. Berzelius, he suggested that symbols of an elements be made from one or two letters of the names of the elements. Right. So what he suggests is that a letter can be taken, one or two letters, okay, from the beginning, and we can give the symbol like that. Okay, for example, if you see hydrogen, okay, hydrogen, you'll see that hydrogen H is there, right? Then you see oxygen, oxygen O we have taken, carbon we have taken C. Likewise, we can take. In the beginning, the names of the elements were derived from the name of the place where they were found for the first time. For example, the name of the copper was taken from Cyprus. Some names were taken from the specific colors. For example, gold, you'll see that. It was taken from the English word yellow. Nowadays, we have got IUPAC, that is the International Union of Pure and Applied Chemistry. Okay, this is an international scientific organization which approves the names, symbols, and units. So many symbols are the first one or two letters of the element's name in English, right? The first letter of the symbol is always written as the capital letter, okay, that is the uppercase, and the second letter as the small one. For example, if you see in cobalt, what we see, so in cobalt you see that, yeah. So in cobalt we have got C we have written and we have taken O in the lower case. Let's take more examples here. See a hydrogen, we have got H. Oxygen, we have written capital O. Nitrogen, you will see that uppercase N is there and small we are not writing. Aluminium, we have taken Al, okay, and not this A, and the second letter we have not taken as capital. Cobalt, it is Co, right? And it's not C and O, that is the capital one. So we need to write like this. Symbols of some elements are formed from the first letter of the name and the letter appearing later in the name. For example, you'll see bromine, we have got Br, zinc, that is Zn. Other symbols have been taken from the names of the elements in the Latin, German, or the Greek one. Iron, that is Fe, which is my ferrum. Sodium, that is my Na, right, which comes from the natrium. Potassium, that is from kalium, that is K we need to write. Therefore, each element has got a name and unique chemical symbol. Okay. Then you'll see that we have got few examples here listed. Nitrogen we have already gone through. See, hydrogen we have taken H. Okay, potassium we have K. Silver we have Ag. That is the Latin word argentum. So that's the reason we are writing Ag. Cobalt we have discussed. Carbon it is C. Okay. Iron it is F. That is the ferrum. Okay. Lead that is plumbum. That's the reason we are write Pb. Okay. So student, you have understood all the symbols as such of a particular elements. I'm sure you have understood the concept very nicely. Kindly like and subscribe my channel Kishore Sir Ki Pathshala. We'll be meeting in the next sections for atomic mass as such.